if you are managing agricultural lands and after a while you realize that over a period of time, over a few years, you realize that the productivity of these agricultural lands are progressively decreasing, then in order to enhance the productivity, you add some external agents to your fields or the agricultural lands. These external agents, they could be referred to as in different terminologies, but irrespective of it, the primary reason you add these external agents is to increase the productivity of your soil or of your land. The way these external agents achieve this increase in the productivity is essentially by ensuring that the water and light that is offered to these fields are being efficiently or adequately utilized. And after that, your crops needs to be preserved from that of the various disease causing pathogens. And also it is necessary for the crops to offer a resistance, or the field to offer a resistance to that of the pests that destroys these fields. Now, these features can be achieved, these features that enhance the productivity of your fields can be achieved when the external agents that you add to it as silicon in them. Of course, silicon in its various form. It can be silicon dioxide in its oxide form, or it can also be in the form of metal silicates. So when you have these components of silicon in them, you have a way to prevent the attacks of pests. You will be able to resist the disease causing pathogens and efficiently use your water and light supply. In addition to that, it might be possible that the land that you are utilizing for agricultural purposes has turned acidic, and it is required that you need to improve its pH so that it becomes conducive for an growth of the crops. And what you are essentially achieving here is you are ensuring that the condition of your field is in such a way that it increases the productivity. Now, turning or neutralizing the acidic nature of your land, increasing its pH, and at the same time providing a conducive nature or environment for the growth of the crops can be achieved when calcium in its various forms are present in the agent that you are adding. Let's say if this agent is a fertilizer, then the fertilizer should have calcium in it, so in order to offer these effects to that of your land, ultimately increasing the productivity. And finally, all these elements should be available in the forms that can be accessed by the crops. So there are various forms these elements, these components could take, and if these components do not assume a desired form that can be accessed by the crops, then the whole purpose of adding these components becomes rather useless. So in order to achieve that, you need to have the right precipitate of these components, and that needs to be ensured by the external agent that you are adding. And on top of it, when you till your agricultural land so that new soil appears at the surface, enormous amount of carbon dioxide is released during this process, and carbon dioxide being a greenhouse gas, this needs to be avoided. And the carbon dioxide needs to be absorbed, and this is possible when the external agent that you are adding has magnesium component to it, of course in its various forms. Now when these components are available in your fertilizer, then essentially you will ensure a greater productivity, or you will increase the fertility of your land and ensure greater productivity. Fortunately for us, when you consider what is required for improving the fertility or the productivity of your agricultural land from that to that of the chemical composition of the blast furnace slag, you see there is a significant amount of overlapping. So therefore what it essentially means is, if we treat our blast furnace slag in such a way that you don't have any leaching of that of heavy metals, and after ensuring that there is no leaching of heavy metals, and it is now perfectly possible for us to deploy this blast furnace slag into the soil, then this blast furnace slag can be used as a fertilizer. It is not only in theory that we can consider this, but it has been practiced on a larger scale. This work reports a long-term experiment of 28 years, wherein two pieces of land, one using blast furnace slag as a fertilizer, is compared to the productivity of another land wherein the blast furnace slag is not used as a fertilizer. So they have two pieces of land. One uses blast furnace slag as a fertilizer, the other does not. So they compare the productivity over 28 years and they find that the one wherein the blast furnace slag is used as a fertilizer, it has an increased productivity of 14% when compared to the other piece of land that does not use blast furnace slag as the fertilizer. So there is 14% increase in the productivity. Now besides that, it is also shown that the blast furnace slag is able to absorb the methane that gets emitted. So the reason methane gets emitted is primarily because when you have a field, particularly wherein the rice grows, now in those fields, the microbial activities, they tend to generate methane. And again, this methane needs to be absorbed because when you are considering huge agricultural land, the amount of methane significantly increases. So we need to have a fertilizer, an enhancing agent that should trap this methane. So blast furnace slag does it for us. So in this way, we have a proof that, but at least in case of rice crops, it is possible for us to increase the productivity by using blast furnace slag as the fertilizer. So besides the different uses of blast furnace slag, now we have one unique, a novel way of deploying the blast furnace slag or managing the blast furnace slag for our benefit, that is by using it as a fertilizer. Now of course, the fertility or the productivity of the agricultural land can also be further increased if there is a supplement of, or there is an enhanced supplement of macronutrients. So these macronutrients can be iron or it can be phosphorus. These are required for the crops to grow properly. So if it is possible for us to supplement these macronutrients, it will be easy, or the amount of productivity that we can expect from a given land would be significantly increased. And on top of it, it should also be possible for us to have an enhanced methane trapping. So even though blast furnace slag has shown to be a profitable way of being used as a fertilizer, and it satisfies these rather properties or these rather required features of enhancing the productivity, if we are able to achieve these as well, that is enhance methane trapping and also offer the plants with macronutrient, the nutrient that is necessary for it to grow, then it is further possible for us to increase the productivity of these crops. And thankfully for us, we are not done with metallurgical waste yet. At least we are not even done with the iron making waste yet, because when we consider the slag of the blast furnace and along with what blast furnace has to offer, it offers us molten iron, which we refer to as the pig iron. So what it essentially does is it offers us molten iron in the form of pig iron. Very rarely we use pig iron for any given application. So these pig irons are often converted to that of steel. So this is a schematic representation of how it happens. So basically it all boils down to refining the pig iron by introducing coke and getting rid of its impurities by using that flux and adding some alloying elements, ultimately rendering us the molten steel. So what we do is the output of the blast furnace slag is further treated in the steel making process, which is schematically shown here, wherein the pig iron is converted into steel, and of course we are adding flux when we want to refine the iron, and all the impurities in that of the iron gets collected as slag. Now this slag is different from that of the blast furnace slag, so this is essentially referred to as the steel slag. And of course, depending on where these slags are generated, we have this basic oxygen furnace slag, we have electric arc furnace slag, and also we have ladle slag. So we have three different forms of slag from where these slags are getting generated. At the end of the day, all these are steel slag as opposed to that of the blast furnace slag. Now before considering the application of where these steel slag can be used, we have to consider its chemical composition, and as you can see, the chemical composition of the steel slag is almost comparable to that of the blast furnace slag, except for that it is rich in iron oxide and it is also rich in magnesium oxide. So two components that primarily differentiates your steel slag from that of the blast furnace slag is that of iron oxide and that of magnesium oxide. So this is the key difference. Now when you take this understanding of the composition of the steel slag, and compare it with what is required to further enhance the productivity of the agricultural field, it is to enhance them. As a macronutrient supply, you need iron, which now is being offered by the steel slag, and also magnesium is offered at the greater amount by the steel slag, and also the methane trapping capacity is greater in the steel slag, primarily because the other composition between the blast furnace slag and the steel slag are the same. So whatever is missing in the blast furnace slag, these is found in a lesser amount, and this is again in a trace amount. These are offered by the steel slag. So ultimately, we can use the combination of blast furnace slag and steel slag. It will increase the productivity of the agricultural land even further. So now in the upcoming 1 or 2 sessions, possibly we will be focusing on the application of the steel slag as opposed to that of the blast furnace slag, and this I believe is rather just a brief introduction of, or a segue into that of the steel slag.